Hello, in this video I will show you how to use Latex to convert your Microsoft document into nicely formatted document. First of all, Latex is a language, so you actually need something that interprets the language, so you need some other program. And for Windows, the program is called Latex, and there are also other programs, but Latex is the most famous one, and you can download it by going to the URL given at the top of the page, and then on the page you have to find what I marked by the orange arrow, and you have to download that file. And once you finish downloading, you have to run the file, and go through very easy process of installation. It's mostly clicking next button, and at the end I think you have to click finish button. And once you are done with installing the program, you have to go to Start menu, then to All Programs, then to Latex 2.9, and then click on TextWorks. Now, for Macs, it's a very similar process. You go to the URL, but it's a different page, and the program is called Latex, and you download it and you install it as any other Mac program. The only catch with this one is that the size of it is 1.8 gigabytes, and that's because Macs doesn't support adding libraries after the basic installation, so you don't have to worry what that means. The point is, if you have very slow internet connection, well, you might want to reconsider downloading it. Another alternative is to use lab computers, and the lab computers in rooms 201, 203, and 204 in Gladfelter have Latex already installed, so it's very convenient. As you can see on the picture, I have included where exactly is the location of Latex. And now let the fun begin. So let's run the program. Oh, mine was already run, so let's rerun again, just so you get a fresh start. And we get empty window, and here you just wanna stay with PDF Latex. And now let's define the simple block of the document. So you wanna start your document with this block, but let me just make the font a little bit larger so you can see. So you wanna start your document with this block always. First line specifies the document class, and this is the regular font size, and this is the type of document. It can be either article, letter, report, or book. So I will use book in this case, since that's what we are mostly concerned about. And title, I will use calculus book. Now for other, I never seen calculus book written by John Smith, so I will see one soon. And now the date. Here you can put, well, you can put January 15, whatever you want. But if you want to use today's date and you don't want to type the entire date, you just have to put slash today, like this. Now the two most important blocks of the document are the begin block and the end block. Between those two blocks is where all of your paragraphs, sections, and whatever you want to put into your document go. This line right here makes a title page, which includes all of this info, which is title, author, and date. So now when I compile, I'll be asked to pick where my project files will be saved. I want to save mine in math project folder, and I want to name my files project. So once I do that, the program compiles and I get the title page. However, we want more than that, and as I promised, I said at the beginning of this video that I will be converting the Microsoft documents. I will open my Microsoft document, and here is my project typed in Microsoft Office. Now let me copy everything up to a picture. And just to warn you, you don't want to copy directly pictures into Latex, it's not gonna work. So everything up to a picture, so let's paste that in, and after we paste that in we get something that's very unformatted. So Latex actually requires to specify where is the start of the section, and in most of your papers you will just use one section and the rest will be subsections. And I didn't copy the section name here, but my section name is sketching planes in 3 dimensions. So let's define start of a section, which would be section, and then the curly brace is the name of the section. And let's run this. Well, we get the section, but for right now let's get rid of the numbers in front, since they don't have any meanings and they don't look very visually nice. So once we add star, the numbers disappear. Now another catch with Latex is that whenever you use equation, like this one here, you want to put $sign at the beginning and at the end of the equation. So it gets very nicely formatted. And it gets much more important if you use if you use equation functions, like using fractions or anything. If you don't put that $signs, you will get an error. In this case you don't get an error, but that's because it's a very simple equation. Now if you put double $signs at each side, your equation gets brought to next line and it's centered and it looks much nicer. So let's do that for all of the equations, and you want to follow that format for your final draft. So that's what we get, but as you see, I've used example in my paper and it doesn't really look quite good. So as I mentioned before, I want to use one section, so my section would be sketching planes in 3 dimensions, but you have to also use subsections. So example 1 would be a subsection. That's a good example of subsection, and I will use star again so there is no numbering, and you have to include the name of the subsection in curly braces. So once I do that, I get a proper formatting for a subsection, and now I have a basic setup for everything but the picture. So let's include a picture. First thing that you have to do whenever you use graphics of any sort in Latex, you have to make an import of the library, and you do that just once. So you have to make call by saying slash use package, and in curly braces you have to say graphic x. Now once you do that, you can actually start including the picture, including the graphics. The command for that is slash include graphics, and in the square braces you can include parameters such as width. You can Google on that more, but for mine I just use width equals 60 millimeters. That means that the image will be scaled so it has width of 60 millimeters. You can also use height instead of width, and in the curly braces that's where the name of your file goes. Now remember, the first time you try to compile by clicking this button, it asks you for the location where you want to store your project. So now whenever you import a file, you have to make sure that the figure or image you're using is inside of that directory. So I will copy picture 1 into that directory. My directory was mod project, so right now it's in that directory, and now when I run the project I will see that there is a picture. Now since I didn't bring my import to next slide, it got included with the previous slide, but that doesn't look nice. I will bring it up to next line, and this will be switched to this. Now I will probably want to center my image, and for that I have to specify the beginning of centering and end of centering. So let's begin centering and let's end centering. So once I do that and recompile, my image is centered. Now let's add some more. So I'll add this paragraph and nice thing with Latex is that it will automatically format it for you, so if something doesn't fit on one page it will bring it up to the next one. And here's my next paragraph, and now let's define another subsection. So I'll copy my section from the Word document. So example 2, so this will be another subsection in my document, and I'll do exactly the same thing as before. And for the equations, I will put dollar signs at each side. And I get the following. And basically the process goes on and on. You can add another subsection and another subsection. You can add more pictures, but it's pretty much repetitive from now on. Another thing that might be useful for you is that you might actually want to comment your sections. At the beginning of the comment is given by percent sign. So you put percent, and let's say this is my section 2. And when you run this, your program doesn't get affected by the presence of this line. This is just for you when you write, just so your comments can tell you, like, what you're doing here and there. Now another thing, once you exit out of here, you probably want to know where your final result is. So your final result would be stored in mod project or any folder that you specified at the first save time, and it would be in project PDF file, and that's how it looks like. Now if you wanna edit, here is your .tex file, so you just run it and you can go on modifying it more. So that's basically it, and I just want to point out that Google is a very good resource for LaTeX. So for example, if you want to do a fraction in LaTeX, you just type in Google how to do a fraction in LaTeX, and you'll get like exact example and like code to run. Thank you for watching this video, and I wish you success with doing LaTeX projects.